Greetings, everyone. Welcome to our exclusive Global Leading Voices webinar campaign. We are delighted to have you join us here today. Please be informed that if you have any questions during the presentation, you may type them into the question box in your control panel. The presenter will answer your questions at the end of the presentation accordingly. Now, without further ado, we will turn the time over to our presenter, who will begin shortly.
Thank you everyone for coming. So today we'll be talking about sort of ISO 31000 framework and how that sort of relates to AI systems and sort of incoming regulations. We'll be covering that, but I mean, before we jump into that, we'll have a look at some of the events that are coming up for PCB. So in the 4th and 5th of October, there's an in-person conference going on. So if you do want to get tickets to that, you can follow the link that's available here. And then in September, there's also an online training course, and in October as well, which you can purchase tickets to as well for upcoming conferences in Paris. So welcome. So basically, we've got two presenters today. There's myself, and so my name is Jefferson. I'm the co-founder of Advai. So we do testing and measuring and sort of understanding what causes AI to fail. And we also have Nick Frost from CRM Energy, who sort of does cybersecurity and sort of understands how to identify the risks and manage to mitigate that and sort of get it right the first time. So we're both going to be talking sort of different aspects of the requirements in terms of how we can sort of look at AI in a sort of a risk-based view and manage that.
Hi, Chris. Don't know if you can hear me now.
Oh, yeah, I can hear you now, Nick. So do you want to take over?
Oh, fantastic. Thank you for covering. Nothing like a good incident response plan. Hi, everybody. Really sorry about that. No idea what happened. 5 minutes before the call, we were all speaking, no problem. So back to it. Okay, 2023, that's been quite a year for AI. I think it's certainly, well, it's been around for obviously for a number of years with the likes of Alexa and Siri, but 2023 has really seen an increase in visibility, I think you could say, for AI, and in particular for a number of particular sectors like the medical sector. Got companies like AlphaFold who looking to use AI for modeling different proteins and helping to identify vaccines for some of the biggest diseases like malaria. The automotive sector is also looking at AI, and we've got a number of case studies. But it's really been the year, I think, for AI 2023. And whilst that's great news, it's showing a lot of value for organizations, adoptions going through the roof. This is also a real key time for us to make sure that we're managing risk accordingly. And so if we look on the next slide for the agenda, this is really what we want to look at today, is just to get a basics understanding of what AI is, in particular looking at the regulatory landscape. But then we want to touch on the threat landscape for AI. There's a lot of information, there's a lot of media hype out there about AI, in particular its adversarial use, but we want to try and take a broader look at what that threat landscape looks like. And as part of that threat landscape, we want to augment that into what a risk-based approach looks like for AI assurance, and in particular looking at ISO 31000. But what is a key part of the approach that CRMG and Advai have looked at here is around not just the risk-based approach, but also looking at stress testing and how that can help you and your organization come up with a good understanding about your potential exposure. And then at the end, we'll finish off with some good practice next steps if you're looking at adopting AI across your organization. But before we do that, we're going to take a look at a poll. So we're going to put a couple of polls for this session. You're going to see the poll question set pop up in a minute, but what we want to understand here is get a general feel to what extent AI is being adopted in your organization. So you've got a number of responses. Our organization is not even discussing AI. B, we're looking, or we've probably adopted AI, but without knowing. That could be a vendor or product, for example. Our organization's knowingly adopted AI, but hasn't assessed the risks. So that sentence needs finishing. Or D, our organization has knowingly adopted AI and has assessed the risks. So if you can vote now, and we'll take a look at the results shortly. Okay.
Okay, yes, we had the poll, and 35% voted for the A option, 24% voted for the B option, 21% of the audience voted for the C option, and 20% for the D option. So pretty much all 25% on all options.
Yeah, that's a good point. Chris, any comments on that? Is that broadly what you're seeing?
Yeah, I think it's sort of reflective of the market, and especially kind of the questions around AI. So I mean, I think where adoption is going on, it's sort of done in a sort of to a degree sort of opportunistically, but there's not perfect knowledge, and it is a challenge to actually sort of assess the risks. So it's a smaller proportion that have done it from our reflection. And I think it's interesting that sort of not discussing AI at all is a larger one, because one of the key things in terms of adoption of AI is if it's too difficult, it's just not even considered, it's kind of thrown out early on.
Yeah, good. Okay. Over to you then, Chris, for the next part.
Okay, so what I'll do instead of the next section is I'm going to take you through some of the sort of a bit of a primer on AI, but also getting to know the landscape ahead of us in terms of what regulation is going to be looking like. So one of the things we'll start off with is just one of the common definitions for AI systems, in fact, and this is actually defined by the OECD. And within this, it's saying that sort of AI is a machine-based system capable of influencing the environment by producing an output for a given set of objectives. And there's two things within that are very important. One is the output, which is in itself a word that has multiple definitions within different regulators and policy in terms of what that output from a system could be it from a generative system or prediction. But also with the objectives, because the objectives of an AI are very important in terms of how it's optimized, how it's fine-tuned, and ultimately how it's delivered as a final solution. So if we dig a little bit more into this definition, and the reason we're looking at this one in particular is because broadly this is reflective of what is being accepted as kind of a global terminology for AI, but also in the context of the EU AI Act, it's being accepted by them as the sort of the main definition within that proposed regulation. And so what we've got within here is it digs more into sort of the outputs that you can get from an AI system, and we're looking more at not just the outputs, but also the degree of autonomy that a system has. And one of the key drivers for AI adoption is that level of autonomy and being able to deploy it in an environment where it's able to operate fairly freely within the remits of its domain. And I think some of the key things that come out of this is that there's a clear distinction between AI systems, which are the systems as a whole, but also AI models, which are the actual tools, components within the AI system that actually do the inference, the prediction, the generation of new data. And those are the ones that are requiring of sort of much more analysis and stress testing as part of the greater whole. So with the adoption of AI, it introduces a whole new potential in terms of threats and bad outcomes. And the reason this is actually quite interesting is because it's not directly related in terms of how traditionally we've looked at cyber controls, in terms of how we've looked at dealing with threats and risks. Because within the use of AI, because it's data driven, because it's based on the information that is around us within our world, we sort of have these focuses upon things such as data poisoning, data leakage, things that are more related to sort of the management and control of data. But also within there is potentially a threat coming from the fact that as we become more used to AI systems, we become over-reliant upon them. And within that over-reliance, that opens up even more vulnerability in terms of adversarial attacks that can take against these. And these could be evasion attacks, denial attacks, which again sort of have a little bit more familiarity in a cyber context. But one of the additional things that we see out this is just generally unexpected bad outcomes. And so when looking at AI and thinking about adoption, you really have to think about how it's managed for unpredictability, because within there, it's not potentially a fully causal solution that can have the opportunity to go out to different areas. And when that starts to happen, you start to see things such as hallucinations, as we've has been in the news with things like LLMs. But then you've also got this inherent bias that's baked into these systems, and that can lead to things such as discrimination, potentially also leading to sort of further issues with regards to leakage of sensitive information. And so understanding those risks within AI systems is critical to being able to deploy them. So what's one of the ways that you can actually start to make yourself ready for AI adoption? So one of the key things that can be coming from this is sort of both organizational readiness, but also AI readiness is another term for it. And what this is basically doing is making sure that the building blocks within the organization are there to be able to firstly understand what the AI is being used for and making sure that it aligns with sort of the objectives of the organization, but also within that use case, understanding that you've got the resources and the process to be able to effectively exploit and support the system in its lifetime. And so this is actually a really interesting spot where we can start to see the ability to integrate with 31,000 in terms of how we can look at the risk management. Because as you're looking at building out the use case for the AI, understanding how it's deployed, you can then start to look at incorporating the clause 3 principles in terms of how the identification of value and risks is done. You can start to incorporate that into the framework, which aligns with so potentially sort of the machine learning lifecycle in terms of how AIs are built. And then within that framework, you can then start to enforce the processes and principles in terms of what you quantify as the value that you need to protect and also the practices that you need to enforce. And within that, that's how you start to have this alignment in terms of how you can identify, manage, and mitigate the risks throughout the lifetime. So this is just a little one to take away. So there's a lot of terms going around with AI, and AI in itself covers a very broad sort of range of things in terms of what you'll see out in the media. But some of the most useful things, and certainly some of the most topical at the moment, are related to things such as MLOps, which is machine learning operations. So that's considered for the whole life cycle of AI systems and how they're trained, deployed, monitored, and then sort of go through the whole process again back to the beginning where data is collected again. We have generative AI, which has been of particularly hot topics since the last year, and that relates to things such as ChatGPT, to the DALL-E models that are creating content and doing it using text prompts to be able to generate new data. Inference AI is related to more traditional classification systems. And then one of the big things that's coming out now, and this is a lot where you're seeing a lot of money spent by some of the big providers out there, but also with regards to some of the new solutions that are being created, is the concept of foundation models, which are these huge AI models that have been trained up on effectively the entire internet to be able to effectively generalize across a lot of use cases. So with that in mind, in terms of AI, it sort of starts to, when you consider sort of how over the last year language models have sort of changed the face of sort of the public conversation with regards to AI, it's no surprise really to see that there's a push in terms of regulation globally. And I think within that, we start to see things in terms of regulation is actually being pursued in most countries around the world in terms of trying to sort of demonstrate that they're looking to control how these systems can be deployed, looking to make sure that they're protecting society from potential harms, and again, fundamentally trying to align how these systems are meant to work when deployed with societal interest. And so within there, we've got different types of regulations. So we have things within the EU, which is sort of a horizontal broad regulation in terms of sort of a common sort of risk-based approach in terms of high-level risk in terms of use cases that would relate to things such as biometric identification, all the way down to things which are a little bit more sort of soft in terms of the Japan regulation, which is more sort of principles driven and also generally more supportive of innovation. So there's a whole spectrum in terms of what's going to be happening. And I think within the next year, 2 years, you'll start to see these regulations coming into play. So what do we have in terms of sort of incoming regulation? So there's actually some common principles that are emerging across these. And so across all of them, we're seeing things such as transparency and explainability being a consistent requirement in terms of understanding. Fairness and non-discrimination is related to the bias, the data that's being used, and the inferences in terms of how that could be affecting sort of minority populations within society. We also have security and robustness, which is, sorry, apologies for that, which is related to the actual control of the systems and making sure that if they are under adversarial attack, they are not likely to leak information, not likely to perform in an unexpected way, or not likely to be negative in terms of their impact and harms on society. And this leads into safety and accountability. So within these systems, AI systems that are being deployed, it's understanding that first that they have been deployed in a responsible and safe way, but also for those processes that have been used to deploy them, there is understanding in terms of who is accountable, who is responsible for making sure that takes place. And then the last three relate to data governance and privacy. So that's really looking at sort of how data is used in these models, human centrism, and social and environmental well-being. So it's really looking at how you align these values with sort of humanity and society as a whole within those. So these are some of the principles that correlate across most of the incoming regulation. So let's have a look at a bit of a case study as to sort of why this is important. So for this, we're actually going to look at ChatGPT. So when this was rolled out end of last year, so it was actually initially blocked within the beginning of this year by Italy as they sort of assessed how it was being used and sort of the risks that were happening there. And what's interesting about this case study is this isn't actually related to any of the new regulation, but this is really based off the application of GDPR in terms of where and sort of who is responsible for the data. And what happened here was that by doing this, they raised a few questions that they couldn't accurately be answered by OpenAI, and which justified the blocking of it. And so what they were trying to look for here was, by allowing ChatGPT to come into the system, how could they guarantee that within Italy that it wouldn't provide false information, it wouldn't hallucinate, it wouldn't provide inaccurate information or information that could potentially cause harm. Going along to sort of more traditional practices, it's how was the data being collected, how were users whose information was used to train the model, how was that being reported? And fundamentally, how could they quantify the requirement to use that data within their system? So fundamentally, these are all GDPR related issues and data related issues. But what this actually forced ChatGPT to do was they had to come back and sort of, in order to improve their product, they had to actually start promoting user trust. They had to identify these areas where the regulator was pushing back. And what this has led to now is that they have this alignment project to help push these things forward. And this is ultimately to reduce risk, prevent harm, and sort of improve trust within the system. So let's take the concept of harms then. So a lot of what we're looking at within the regulation is actually intended to prevent harm to society. And one of the biggest ones that you'll come across a lot is related to bias and discrimination. So there's a lot of things within the use of AI models that are a result of incomplete data, data that contains toxic information, and basically all of these patterns and bits of information are baked into models. As well as that, we see things such as links to sort of safety, links to privacy. And in terms of being able to understand sort of how the systems are used, there's a real push for being able to get away from the black box approach, which is sort of basically you use the AI to pull up everything and then sort of put an input, create an output. There's this need to push for explainability. to understand why a system is making a decision, especially if you're looking at things like financial services or any sort of any particular method that might be sort of looking at saying we will change or impact your life based on this model's decision. And then the final thing, which is really interesting, is security threats. AI potentially poses this huge new vector in terms of where threats could be coming from. And especially if you look at things like generative AI that are used to generate code, understanding how that generated code could be injecting new vulnerabilities into a system is going to be a huge challenge. And so generally understanding how AI causes a security threat is going to be a key of this regulation. So what are the things we can expect ahead of us? So there's definitely going to be a push in terms of high-risk use cases. And when I talk about high-risk use cases, specifically within the context of the EU AI Act, we're looking at things like biometrics, police enforcement, evidence gathering, automation of industry and infrastructure, to name a few. And basically, these high-risk use cases are going to be under much more scrutiny than, say, lower-risk use cases, which may just be the automation of sort of back-office systems for sort of sorting and cataloging data. There's also going to be a big push in terms of the focus on discrimination. So a whole thing in terms of the harms is understanding how these systems impact society, how they may minoritize certain groups of society, and how it also may amplify misinformation based on that bias. And so understanding sort of how that is baked in is going to be a big thing as well. I think this leads into sort of the fact that as this grows over time, there's going to be an extended piece in terms of the regulations are going to become more coherent just for AI, but I think there's also going to be the impact on additional information security, data regulation, cybersecurity. I think we're going to start to see all of these types of regulation updated to account for an AI-driven world. The good news is this is probably going to lead to better standards though. So what we're in at the moment is a principles age in terms of how we build, develop and deploy AI. It's optimistic, it's ideal. And I think we're going to see this over the next couple of years, a real push in terms of the standards for quality, risk management and all of those things related to specifically AI systems. And we're already seeing that within the ISO. So we see sort of there's current standards for actually detecting and managing bias within a system. But I think the immediate future is going to see some of the draft standards that are being done in terms of how you manage AI, how you make sure that it is aligned with your processes coming out as we move through. So what does this mean for kind of sort of what we've been doing at Advai? So basically, because we work on understanding how AI fails, but also importantly, as it goes through its life cycle, how different stakeholders are responsible for different aspects of it. We effectively sort of understand that there's different risks, there's different issues, and there's different challenges that are having questions asked at different stages, be it from business understanding, where it's more of a business level function to understand the use case and the risk, through to model builders who are actually doing the development and experimentation and need to know the performance or the key metrics for how to make a strong model, all the way through to more traditional monitoring processes. All of these different aspects have different KPIs which are related to understanding the performance of the models and the AI systems, and fundamentally being able to measure and control the risks that could be posed by those systems. So within the work at Advai, we look at understanding how to break, measure and deploy AI successfully. So this leads us on to the AI threat landscape.
Thanks, Chris. So one of the points that we wanted to cover here was to give I suppose, a pragmatic view of what the AI threat landscape looks like. I think it's important to recognise what changes we see, what changes we expect to see, but also let's not get carried away with the adversarial nature. There's a broad range of threats that we must consider as part of this change in the sort of renaissance we see in technology. So yes, the sophistication of cyber attacks definitely has compounded with technology evolution. We know that there's an uptake of AI for adversarial and nefarious individuals, and here's a few examples of the intentional AI attacks. We're seeing a lot of media attention around cloning. So voice cloning, for example, and there's been cases, a number of cases recently, one of which was a bank in United Arab Emirates that recorded the voice of a senior individual in the organisation, used that to tube a branch manager into transferring a large amount of money. This is happening. There are other attacks as well, which is making changes to road signs, for example, that can lead to a lot of the AI systems in automotive industry to make potentially some very dangerous decisions. And so the attacks are really quite sophisticated in some ways, using cloning, but also very simple in terms of achieving an unhelpful output. One of the things to consider though here is, like with all cyber-related attacks, where we're going to see I suppose you could see an accelerated evolution is likely to be those attacks that are financial related, because of course the money that gets generated, the smart organized criminal gangs will reinvest that into more sophisticated attacks. So considering some of those cyber threats from a finance perspective is something that really needs to be taken seriously. If we go to the next slide. But we also need to not forget those accidental threats. I know they're not as exciting as the intentional threats, but those accidental threats, or let's say non-intentional, are also potentially very damaging. We've seen examples where stock markets around the world, the AI has acted out of kilter to what was previously considered, and as a result there have been some unexpected crashes in the stock markets. We also seen situations that are far more alarming, whereby the number of systems on airplanes, for example, Boeing is an example where the system there, AI-based system, felt that the plane was about to stall, and as a result it kicked in the autopilot that nosedived the plane to try and gather speed, and as a result Boeing plane crashed. So a number of key features here, and the key point here with a lot of these examples, when you talk about health and safety in individuals' lives, you talk about stock markets, AI is being used for some really critical decision-making activities, and that's why the risk and understanding those risks is really, really important for us and for senior management to appreciate. But if we look at a threat taxonomy, this is just our threat taxonomy we use at CRMG. A lot of these won't necessarily change, and if you click another button, Chris, you'll see that no, not that one. But if you go back, but a lot of these threats in the threat taxonomy, they're not necessarily intentional in nature. So we might have unforeseen effects of change. We're likely to have theft of personal information, theft of IP, business information. These are common attacks that effectively are going to be accelerated with the use of AI, either accidentally within the organization, because there's going to be rapid adoption, mistakes are going to happen, and there's going to be pressure on IT teams and security teams, because the business is going to see the use and adoption of AI as a competitive advantage. And the argument that we tend to hear coming back about conducting thorough risk assessments before releasing AI is, well, you're effectively reducing our market penetration. We have to be adopting AI and doing so quickly. So there has to be a balanced approach, if you like, between ensuring innovation and creativity, but also managing risk. But none of these threats here will necessarily change. This is still applicable. But if we go to the next slide, there are a distinct set of threats that we feel are particularly important to consider for AI systems. We've touched before on adversarial data poisoning. I think data scarcity, as Chris mentioned before, a lot of these AI models learn from large data sets. The required level of data and the accuracy and integrity of the data is not there. then you may end up with a very precise output, but very inaccurate output as well. But theft of sensitive business information and unauthorized access to model source code, I think this is something that, you know, is going to be important. There's obviously a considerable race on to achieving a mature level of AI capability at a national level. So there's a national level of interest in terms of understanding what other countries, other nations are doing in this space. Okay, if we move on to the next slide. So, okay, so we know what this threat landscape looks like. So how can we effectively achieve an understanding about what mitigating controls need to be in place? So this is a very simple example. There's lots of examples out there. This sort of threat and controls matrix that you see on this slide. This is what we produce the CRMG for a range of different environments and different systems. But you know, one of the areas of focus and where I would recommend organizations to invest the time and effort is establishing a matrix like this. It can be static, it can be dynamic if you've got threat intelligence and control information. But the idea is to focus on those controls that really matter. As long as you have conducted your threat profiling for the AI system, you clearly understand what threat you're concerned about, you can then start to identify what are the controls that really will make a difference. And they're the controls that really need to be implemented and monitored on an ongoing basis, because they are the ones that hopefully will start reducing any exposure to the types of attacks that we're seeing so far. Okay, next one. But more broadly, so that's really looking at the threat landscape, but more broadly, what I want to do here is understand how organizations can adopt a risk-driven approach to AI assurance using 31,000, or it could be any risk management framework. But the reason being is I want to talk about this is there's a much broader picture that we need to be able to understand and implement to ensure that we've got end-to-end coverage for when we're managing risks for AI systems. Okay, next slide, Chris. So at a very high level here, what we wanted to do is to highlight the importance of, I suppose, what we call traceability and raising the information that we gather when we're conducting our risk assessments right the way through to communicating that to the board and the executive committee. That's important because we have to have that traceability in place. We have to be able to show the evidence and be able to highlight what risks we're reporting, how we've assessed those risks, so that we can provide a level of assurance and confidence to the senior stakeholders about the potential consequences if that system is adopted without the necessary controls in place. Now, it's always quite a difficult argument to present because you feel that you're the negative element in the room when you've got a lot of people excited about AI. But hey, that's our job in security and risk management. We have to be able to, yes, talk certainly about the benefits, but also highlight the potential consequences. So what does a sort of a risk, ecosystem architecture look like? And this is the point that I want to highlight in terms of what good looks like for risk management. We've got it for cyber risk management. Quite frankly, these are the key components that you would apply to any risk discipline. So there's a lot of focus around the assessment. How do we identify the particular threats? Have we got the right controls in place? And there are a lot of vendors that will be talking to those particular points, okay? Because everything either has to have AI-enabled adoption in cybersecurity these days, but please consider those other aspects here. We've got governance, for example. We need to be able to educate the stakeholders and the decision makers about potential consequences of adoption of AI. There's reporting. We've got to make sure that we convey that information in a manner that the business understand. Now, this is all, this is nothing new here. This is the work of what we do as security and risk professionals. But what we are discovering is a real interest from I suppose you could say, those bigger blips on the radar when it comes to risk management, such as enterprise risk management. You know, they're getting really quite concerned about AI because they're also seeing this rapid adoption, but they don't really quite understand it. So this could be a good opportunity for us to now link with other risk disciplines in the organization to be able to highlight that. And we need to monitor it. One of the things that we don't do generally in risk management and cyber risk management is we don't monitor. We tend to carry out a risk assessment and we'll come back either a year or 2 years later. Well, AI is going to change very quickly, so we need to monitor those more effectively. But that's broadly the sort of the risk architecture, and we'll share these slides later for you to consider these. What is important though from an assessment point of view, as I said before, sometimes one of the challenges here is to provide a realistic view of what consequences look like. So here's a typical risk assessment approach. This is generally what 31,000 would suggest. It's also definitely what 27,005, which is obviously the specific standard under the parent standard of 31,000. But what is very important here is helping organizations to determine and understand what business impact looks like. Because there's no point talking to them about sophisticated threats and controls. Yes, we can do that, but what is important first is to ensure that they understand, the types of consequences that can occur if risks are not managed. So if we go to the next slide. So one of the ways in which we tend to articulate impact, just starting off that journey, is to be able to make that link to the data, the systems, if you like, and how those systems support particular processes. And it may well be that there are a number of systems that support a broad process, but actually some are more critical than others. So this is a useful exercise in itself from a risk assessment perspective. But if we can make that correlation between those systems and the processes it supports, that can help convey that level of criticality. And one other tool that we use quite frequently is this business reference table. So a criticality reference table. And the idea here is to be able to present a range of different business impact categories, but also to be able to provide some quantitative, ideally, or qualitative descriptions for each of those ratings. And you can start to build up a sort of a scenario and a narrative in terms of what consequences could occur. Loss of operations, unhealthy level of reputation, you've got regulators on site, you've got financial impact, but these are all realistic. And these, by the way, are decisions that need to be made by the stakeholders, not by the security and risk professionals. Okay, next slide. Over to you, Chris.
Thank you, Nick. So what I'm going to do now is I'm just going to take you through some of the stress testing approaches that you can start to look at when it comes to AI. And when we're talking about stress testing, we're looking at how we can stress an AI model in terms of understanding where its breaking points are. And why this is important to risk exposure is that this is where we start to align with the assessments that you've done in understanding what are the threats that are most pertinent, but also the ones that are most critical. So this is where you can start to effectively evaluate the models for those particular criteria. So one of the things we do with Advai is we use a technique called Adversarial AI, which is an incredibly useful tool in terms of evaluating different AI models. And what is normally done when you're assessing these models is you tend to just review them relative to held back training, testing, and validation data. And you can sort of look at common benchmarks in terms of being able to see how they perform against other systems. But the trouble with this is there's a lot of kind of implicit thinking that's kind of been baked into these systems, and they're not generally built for robustness. And this is where you start to be exposed to risks, areas where if information comes in from outside the sample of training information, then it's very likely that this could start to cause the systems to fail. And what we can do with adversarial testing is this allows us to be able to very quickly identify where the systems will fail and how quickly they will as well. So this is sort of one of the approaches we use at Advai. So some of the different assessments you can do is you can start to look at traditionally sort of measures for performance. So this is actually one of the basic things that is generally done for all AI systems, and this is using the held back training data. And this is sort of fundamental in terms of just making sure you've actually built a model that performs, is accurate, and can actually do what you expect it to do. And within this is sort of generally part of the course when you do AI building. Where it starts to get more interesting is when you're starting to look at the robustness of a system. So this is where you want to understand how is the system going to deal with being deployed into the actual environment that's meant to be working in? How is it going to be dealing with sort of users who may not really know how to use the system? How is it going to deal with data that might not be in a structure that it's expecting, or even adversarial attacks? And what we can do within the robustness testing is this is where we look at understanding how quickly the model can be exploited, how some of the optimizations might have caused it to fail. And what's done there is it's very sort of clever in terms of how it tunes data to be able to actually find that quickest path to failure. And the more robust systems that you'll be working with will generally be able to sort of resist those types of tests more easily. So this is actually a really critical point to understanding exposure to those types of risks. But then the last one is really understanding reliability. So this is sort of stepping away up into the AI system a bit more away from the model. And what you tend to have within here is you can actually look at sort of how the system as a whole is responding, but also if you're starting to get consistent behaviors and expected behaviors from the model and the AI system as well. So within here, you can start to understand, right, if this is deployed, can I count on it to actually do what we're expecting it to do? Can it work within a specific time frame? And this is more akin to some probably more of the traditional sort of development operations things you'd be looking at in terms of metrics, but it is also looking at the data that is produced. Again, look how the input data and the output data vary to understand if the model is fundamentally reliable and safe. So within this, there's a few key points that we can come back to in terms of what we've covered here. So one of the things that is definitely for certain is that regulation is imminent. And as that becomes adopted, there's also going to be legal consequences associated to the adoption of AI and use of AI within different countries and regimes. But also there may be a requirement to actually register high-risk systems to understand how they're being used. And as with any new technology, when it is adopted, there are going to be new threats that are brought into an environment based on that technology, and AI is no exception. There's multiple threats in terms of poisoning models that can actually sort of generate code. There's generally sort of, as Nick said, a whole new arsenal of cyber enhanced AI tools that are available as vectors to come in, and understanding how your risk management framework needs to adapt to accommodate that is key. And then finally, we've got exposure to businesses to these new risks. So understanding how the business is exposed with these potential sort of new risks involved within the organization, and really how to be able to benchmark, evaluate, and fundamentally get the key metrics that are needed to mitigate these challenges using a risk-based approach. So these are all achievable within the frameworks that we've looked at, and these are some of the key takeaways for this.
Okay, I'm launching the poll question.
So we've got one more poll, so I'll just talk through the different options here. So really what this poll is looking at is what's the main concern with AI in the workplace. So the options we've got are lack of understanding amongst decision makers, so enabling sort of to make a risk-based decision. Uncontrolled adoption, so that's sort of using APIs or bringing AI in from the labs to critical processes. AI-enabled cyber attacks, so when we're looking at how cyber criminals can leverage the power of AI and deep learning to effectively negate cyber defenses. And last one is stringent regulation that clashes with innovation. So how is sort of the incoming regulation going to hamper the adoption of new techniques, technologies which are AI-enabled?
Okay.
Okay, we have 41% of the audience that voted the A option, 28% which voted the B option, 23% C option, and 8% the D option.
Interesting.
That's quite an interesting one, yeah. And I think that points to quite an area of concern for me personally, because if there is the biggest number there saying there's a lack of understanding, that seems to be inversely proportional to the level of adoption that's that's underway in organisations. So, okay, well, that's good to know. Okay, so we're going to finish off with the last point, and then we're going to have about 10 minutes for questions. So this is just a very high level set of next steps, and this is our view in terms of what steps organisations should take. And again, this is about steps that enables a risk-based approach, but without impacting innovation, creativity in organizations. It's meant to be a pragmatic and friendly way of ensuring that risks and risk assurance for AI and AI systems are thoroughly understood and acted on accordingly. So really it's about understanding how AI is being used today, and that may require an investigation to your suppliers who are using AI, but possibly you are unaware of that. Once you've understood that, then it's about determining the extent to which those risks are understood in the organization. So step 2 is about recognition of AI and the risk landscape across the organization. 3 is really all about not going out and recreating an entire approach to assessing risks to AI, and there shouldn't be. We're looking at incorporating AI and the data sets that allow you to accurately and objectively assess risk in an existing architecture. But remember that architecture is not just about the assessment piece. It's really about the governance. It's about making sure that there's clear lines of communication, there's good baseline standards, so that everything is done in a structured and consistent manner. 4 is all about risk assessments and how we can accurately identify and provide that evidence and traceability if you ever get questioned about prove that this is a risk, and you've got a solid risk assessment that can show that line of correlation to how you calculated the risk. And then point 5 here, as we said before, whether you're looking at cyber risk or any risk, it's a pretty dynamic environment, especially when it comes to AI. So monitoring and looking at understanding what are those triggers that should initiate a review of your risk assessment to determine if additional controls or actions need to be put in place. So there's 5, simple steps that can get you started in taking a risk-based approach to AI and AI assurance. Okay, Chris, I think we're now into question time. So.
Okay, thank you, Nick and Chris, for delivering this very informative webinar. Just a reminder to the audience that PCB offers training and certification courses showing dedication in managing data protection as well as risk management frameworks. Now, without further ado, we'll go and answer some of the questions from the audience. The first one is, what's the difference between data leakage and evasion attacks?
Yeah, so evasion attacks are actually could be considered as sub-threshold attacks. So basically what you're trying to do within the system is actually try and make the AI so it doesn't result in a specific classification. So effectively you're trying to interact with the AI system without actually setting off an alert. So you're trying to remain sub-threshold and evade classification. Data leakage is slightly different, and this relates to actually you can look at it in the context of AIs that are deployed to endpoints, and they're just returning lists of information or classifications which expose sort of the inner workings of how the AI was trained and the classes it's designed to work for. Or it can also relate to sort of in the context of LLMs, actually sort of it releasing sensitive private information from within the model. So this is where you're starting to see that the information is not handled in a way that would be compliant in a sort of data privacy perspective. So it's that leakage of information. So those are 2 of the examples that hopefully highlight the difference.
Thank you, Chris. Okay, another question is how should AI risk be categorized as cybersecurity risk or an independent business risk?
Okay, I would certainly say AI risk needs to be considered at an enterprise level. It may be, I mean, it can cover all areas. Don't get me wrong, but I think we're likely to see, you know, if you look at enterprise risk, you know, they tend to focus on strategic actions. You know, they tend to focus on financial risk. It could be operational risk. So it's the big sort of, you know, areas of risk in the organization. Yes, it is important for cyber risk, but I think it needs to be handled and understood within enterprise risk management teams. Now, in cyber risk teams, we can do a very good job of providing our element of how AI can result in a cyber risk, but ultimately it's about enterprise making those decisions.
Thanks, Nick. Okay, another question. How do we ensure integrity of information coming out of an AI tool like ChatGPT?
It's a great question. So I think it's currently it's somewhat of an imperfect process, but there's different techniques that we can look at in terms of using sort of guardrails as one of the new sort of much talked about ways of effectively doing some sort of systems engineering around the inputs and outputs. And so what you can start to introduce there are different methods for validating the structure of the information, validating that it's you can sort of call in other systems to actually go through and reference and look for sort of similarity to try and make sure that that it's within a specific scope or isn't releasing information that has potentially a sensitive nature. And I think sort of understanding how, especially with ChatGPT, which poses an interesting problem because it's not quite replicated. You have to understand the similarity of that information to that which you're either trying to protect or prevent. So I'd say the best technique currently is really just to look at guardrails and implementing the different interfaces that can be used to effectively negate some of the different risks about the integrity of that information.
Thanks, Chris. Okay, we have another question. How best can one protect the government from cyber attacks as they have outdated systems and knowledge of AI functionality is at beginner stage?
Yeah, that's a good question, and I can understand where that's coming from. Well, firstly, I would say, so there's two things that immediately leap to my mind to that question. One is making sure that you've got the necessary checkpoints in place that ensure that the risks to AI are understood. And I think that's particularly pertinent with governments because they are probably, you know, they have a low risk appetite, if you like, to a lot of private organizations. I think the second point here, though, with any organization, whether it's government or private, we're seeing an elevation in social engineering type of attacks using AI. You know, we've lots of deepfake videos and what have you out there. That's fine, but that is something that really needs to be considered. And there's some simple activities that you know that you can look out for. You know, there could be an announcement by a government, and that may attract a lot of attention. And let's say phone calls to call centers. You could be a retail organization that that it's very clear when your end of financial year is. Therefore, there's going to be a lot of activity for the finance department, and they are the moments in which these types of social engineering attacks will try to exploit. So you do need to look at some of the dynamics of your organization, whether it's a public body or private body, to determine when those types of attacks could occur.
Thanks. Okay, and the last question for today is how to ensure data protection in open source tools in AI.
So there's a few different techniques that you can start to look at. I think what's interesting about this is this actually looks at sort of the data operations component. So if you've actually got a good corporate data strategy in terms of how you collect, curate, version, and effectively manage the access to that information, you're off to a good start, and that's before you even get to sort of the AI component of it. So within there's a couple of aspects. So you have the option with sort of working with effectively the proprietary information that you as a company or organization you'll collect, and so that's generally considered a bit safer. But if you're starting to bring in open source information, what you need to start to do is just sort of be a bit more critical in terms of how that's fed into the AI models that you'll be building with it, but also trying to understand if there's things such as poison data within the open source information. So when you're dealing with, especially for training, when you're dealing with open source data and trying to pull that in, you should really be looking at sort of, okay, does this contain features, metadata, specific information that could be used to actually introduce some form of weighting or bias or specific backdoor into the model. So a few additional checks in terms of just doing that would be required. But fundamentally, I think it's down to sort of the data management strategy. So being able to make sure that you've got that curated and controlled even before training is key key step to mitigating that.
Nice. Okay, thanks Chris and Nick one more time for being with us today, and thanks to the audience for joining us. Just be informed that this session is recorded and it will be posted on our website and YouTube channel along with the slides of the presentation. Hope to have you in our future webinars as well. Thanks and have a great day.
Thank you.
Thank you.
Thank you. Bye now.